So how do we sketch a derivative given the original function? So using those same principles, we want to try to sketch the derivative given the graph of f of x. So again, the first place we're going to start is we're going to look at that horizontal tangent point. Okay, so we're going to look at this horizontal tangent, the horizontal tangent points here and here. Okay, and here. And let's just assume that that dot is at the horizontal tangent. Okay, it's a little bit off, but so we're going to plot our x coordinates, sorry, our y coordinates of our y prime graph here, here, and here. Okay, and then we can use the fact that this is an increasing slope, so positive slope. This is a positive slope, but it's decreasing in slope. So we know that it's positive decreasing. We don't know the shape of this. Okay, if you think it looks parabolic, we can kind of think it's linear, but we don't know that this is linear. But we know it's going down. Okay, so we know that this is it's positive going down. When it goes like that, we know this is negative going down as well. So this is negative going down. Now one thing we can look at then is now this point here, where it inflects. Okay, this is going from negative decreasing slope to negative increasing slope in this direction. So that point here, we can just kind of line that up and say at this point it's going to start to come back up. The slope is gone from decreasing to the slope increasing, and it's going to increase and increase until we hit this 0. Okay, so this is going to be increasing slope until we hit there, and it continues to increase here until we hit that inflection point. Okay, so here's another inflection point here. Now it's gone from going up, now that slope's going to go back down. It's going to go back down to 0, and now we're in negative slope down here. Okay, and the degree at which these slopes are going, it's hard to tell. Okay, these in fact could be linear pieces. We're not really quite sure. Okay, but we do know that it is going down here, and then at that point the slope's decreasing, stops here. It starts to increase, so it's going back up. So it's increasing slope all the way through that green region, so the slope chart is going up. So again, we want to start with the horizontal tangents. Those are the easiest to identify. Then we want to check for positive and negative slopes, and then we can look for these inflection points, which indicate where the graphs stop going down and start going up, and vice versa. So for tangents and normals, what we want is we need a derivative to calculate slope, and we need an x and y coordinate. So when we have a function that looks like this, okay, we have our x coordinate. The first thing I'm going to do here is I'm going to calculate the y coordinate given that x coordinate. So ln of e to the pi is pi, so we end up with sine of pi, which is 0. We have the coordinate. We need to now know the slope to get the tangent and normal line. Okay, so we want, in this case, just a tangent line. We want the derivative, so we're going to need to use chain rule. So cosine of ln x. Okay, make sure you differentiate outside, leave the inside, and then we apply as a chain the derivative of the inside. So calculating the derivative at e to the pi, we're going to end up with cosine of ln e to the pi, which is pi, cosine of pi, 1 over e to the pi. So cosine of pi works out to be -1, and so we end up with -1 over e to the pi. So the equation of the tangent line then, the tangent line equation this equation then works out to be y equals, I'm just going to plug it in, put it into the point slope form, x minus e to the pi plus 0. Okay, so there is our tangent to this graph at e to the pi, x equals e to the pi, y equals 0. And again, you should graph these just to confirm them and also see what these graphs look like.